All right. We talked last about, coming up with the initial spacing of the stirrups, designing the initial spacing. Again, when you design the initial spacing, you got to have established already VU critical VU. So I think what we'll probably do right now is just maybe go through an example to show you, just what the steps really are. And we'll sort of walk ourselves through it. So let's say that we have a beam. The beam's 12 inches wide, and it has an effective depth 20 inches. It has concrete strength 4 KSI. And yield strength of the steel that we're going to be using is 60 KSI. We're going to be using number 3 U-shaped stirrups. Okay, and what we're going to be asked to do is design a spacing for this beam that I'm about ready to give you. Okay? Now again, we're getting into design, so there's a lot of ways that this could go. I mean, conceivably everybody in here could be doing the right thing, and you could come up with different designs. What is not different between everybody is the initial spacing. I mean, the initial spacing is going to be a calculated spacing. It's going to be, point something something. You're going to have a couple decimal places behind it. Of course, we don't really, in the real world, space with fractional values or decimal values, but that initial calculated value would be the same for everybody. So, anyway, that's going to be our beam, 12 inches wide, 20 inches effective depth, 4 KSI. Concrete, 60 KSI steel, number 3 U-shaped stirrups. Okay? So, with that being said, and that being our beam, let's go ahead and give you a beam that we're going to design for. And since this is our first example, we'll sort of make it pretty plain. We'll just say it's a beam that's 20 feet long. So I'm only going to show you 10 feet of it, and we'll say that there's a total factored load of 8 kips per foot on it. So that's already been factored. It's total. That means it's got dead and live load in it. We're going to say that includes the self weight of the beam, so just everything's all rolled up inside of that 8 kips per foot. It's a 20-foot long beam. I'm only showing half of it because the other half's going to be the same. All right? You could tell me on this type of beam that the reaction, it's 8 kips per foot, 20-foot long beam, this reaction on the side I'm showing would be 80. So my factored shear diagram would be, again, you're just looking at half of it. It would be like a shear diagram that you've seen many, many times before. Down to 0 in the middle, starts up here at 80 kips. All right? First thing we want to establish is what is VU critical. Okay? VU critical's the shear that occurs out from the face of support to distance D. In our case, the distance D is 20 inches. All right? So VU critical is going to be equal to the slope of this line. It's going down 8 kips per foot times the distance that I'm coming out, 20 inches. Of course, I'm going to express that in feet because, again, I'm in kips per foot, plus where I started out that line, which is 80 kips. Basically, y is equal to mx plus b. VU critical on this comes out to be what then? Okay. Call it 66.7 kips. That's what I initially have to beat. I mean, the code, the ACI code is going to say you got to beat that value. You got to have a shear capacity of your beam greater than 66.7. All right? Once we've established that, like we talked about last class, it's really a two-step process. All right? The first step in this process to establish the initial stirrup spacing is to say, I'm going to calculate what my VS is initially. And that is going to be equal to VU critical divided by phi, which is 0.75 for shear, minus V sub c. Now you're going to have to calculate V sub c for me. V sub c is 2 square root of 4,000 times your width of 12 inches times the effective depth of 20. And again, I divide it by 1,000 since we're working in kips up here. 30.36. Okay, you could call it 30.4. Okay, so VS initial comes up to be what? VS initial comes up to what?
58.23.
58, call it 0.3 kips. Okay? You have to have your beam supply of VS initially of 58.3 in order to make this work. So that's the first step. The second step then is pretty simple. You're simply going to say the spacing to get me 58.3 kips is AV. Again, I'm using a U-shaped stirrup, so AV is 2 times 0.11 at number 3 bar, times 60 KSI FY, times a D of 20 inches, divided by that 58.3 V sub S kips. And so my spacing initially comes out to be what? Well, give me a decimal.
4.52.
4.52. So my spacing comes out to be 4.52. I would need, in order to get me 58.3 or 58.23, whatever we said, in order to get me that, I need a spacing of 4.52 inches. Of course, you're not going to use 4.52 inches. You're going to use what? 4. Okay? So our initial spacing here starts out at 4 inches. Now, if you wanted to go ahead and check this for that everything was working out, you could go ahead and you could say, well, let me actually calculate what BS is at 4. And then I could go ahead, this is just a check, but your VS at 4 would be that. What would that be? .66. I only needed a V sub S of 58.3, so that makes sense. I'm dropping down. And if I wanted to even do a further check, I could say, hey, what's my design capacity when I've got a 4-inch spacing? Well, it's 0.75, that's what phi is. Your V sub C is 30.4 kips, and your V sub S, you just told me, was 66 kips. So what is that, your design capacity at a 4-inch spacing now? It's just 96.4 times 0.75. 72.3. And that should make you feel good because, again, you had the beat VU critical, and so that proves that you did. It proves that you did stuff correctly. All right? So our initial 4-inch spacing does work. Everything is, what I